Hello friends, in this video I'd like to solve the following problem from the Saudi Arabia Balkan Mathematical Olympiad Team Selection Test, year 2013, problem 23. We wish to find the area of the following figure, described by the following inequality. X squared plus y squared is less than or equal 4 times the absolute value of x plus 4 times the absolute value of y. It's a nice problem, not very difficult. Here are my hints. First, denote our figure by this capital letter F, and notice that for every point xy is in our figure if and only if plus or minus x, plus or minus y belongs to our figure. Where plus minus can be we can choose it freely. So we can have plus x plus y, plus x minus y, minus x plus y, minus x minus y. And so we have some kind of symmetry going on. 2 axial symmetries and 1 central symmetry. So by using that, it suffices to find the area of our figure intersected with the first quadrant and then multiply by 4. And recall that x minus a squared plus y minus b squared equals r squared is the equation of a circle with center AB and radius r, provided that r is greater than 0. So give this problem a try and I will see you in just a minute. So as I suggested, let f be our figure. Notice that since since function which maps t to t squared and function which maps t to absolute value of t are even, they are even functions, we have x, y is in our figure if and only if plus minus x plus minus y is in our figure. And that allows us to say that the area of our figure, which I will denote by vertical bars, the area of our figure is the same as the area of our figure intersected with the first quadrant times 4. Times 4, because we have 4 quadrants and we have symmetry. So let's just now concentrate on the first quadrant. So let x and y be greater than 0. Now, notice that we have the following equivalent conditions. xy is in our figure if and only if x squared plus y squared is less than or equal, and now, since x and y are greater than 0, on the right hand side we have 4x and 4y. That is equivalent to saying that x squared plus minus 4x plus 4 plus y squared minus 4 times y plus 4 is less than or equal 8. That is equivalent to saying that x minus 2 squared plus y minus 2 squared is less than or equal, well, 8 is 2 square root of 2 squared. So it's an equation of a circle with center 2, 2, and with radius 2 square root of 2. And now I have prepared in advance a nice drawing, because I'm not that good at drawing circles. So, for example, here's our entire figure, which has 4 congruent arcs of a circle. We are talking about our first circle, about this one. So we wish to find the area of this set. It's a circle centered at 2, 2. Here. It has center 2, 2, and has radius. Now, crucially, I will divide my figure into two pieces. Semicircle with radius 2 square root of 2 and triangle. So maybe let's mark that it's, here we have area 1, here we have area 2, and let's compare them, let's compute them. What's the area 1? Well, it's a triangle with what sides? Well, we need to find x and y intercepts. So maybe let's start that with noticing that if I have what's this point basically. So notice that if x equals 0, then 0 minus 2 squared plus y minus 2 squared equals 2 square root of 2 squared. What do we have? Here we have 4, here we have 8. So it's y minus 2 squared equals 4. So y minus 2 equals plus or minus 2, but we will choose 2, so y equals 4. So this point right here is exactly 4. So the area of our first triangle, is 1/2 base, which is 4, times the altitude, which is also 4 by symmetry. So it's 8. And what's our second area? Well, it's a semicircle. The area of a circle is pi r squared, so it's 1/2 pi r squared. So it's 8 over 2, 4 times pi. So the area of our entire figure, it has 4 such triangles and 4 such semicircles. So our total area, so the area of our figure, it's 4 times 8, which is 32, plus 4 times 4 pi, 16 pi. And that is our answer. Our area equals 32 plus 16 times pi. And to be honest, that's it. Maybe last thing before you go. Actually, our figure, it's everything inside our curve. So it's not just our curve, but everything inside it. The area of this figure inside it is this. And yes, we are done. Thank you very much for watching. I will see you next time. Goodbye.